So I hope I have convinced you all all guys, I have convinced you that propulsion system is absolutely crucial, and it's a critical system in the satellite. And I think it's interesting if we have a, whoops, I think it's interesting we have a look, okay, but let's see what's being launched, like currently, what's being launched nowadays. So if we have a look at the data, we can see that 80% of the new satellites that are being launched today are actually very small satellites. They are not satellites like the Sentinel-1 or Sentinel-3. They are satellites which weigh less than 100 kilograms, which are basically what we call nano and micro satellites. And why? Well, the reason is very simple. Since we are being able to miniaturize lots of technologies, the thing is that now we can do more or less the same things. We can have the same functionality, but in a much cheaper way. So the cost both of manufacturing and launch and to launch, they are very, 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 very low. So this is what we call the new space race, actually, which is this democratization of space, in which a lot of new companies are arising with new business models, And one of the most interesting things is that we are being able to perform almost the same functionalities as the largest satellites, but with very small platforms, what we call CubeSats. And just as a matter of interest, we can say, okay, 2020, which has been quite a difficult year for almost all industries, because it had, obviously because of the pandemic and the COVID-19, but 2020 for space has been quite a good year. And let me tell you why, because actually the value of the small satellite market has been multiplied by 4 only in 2020. Sorry, I can't hear anything. I think you are hearing me correctly, no? Well, I will continue. I don't have more. Okay, I will continue because I was just seeing a message that Igor couldn't hear anything, but I think it's a problem of his. Okay, so let's continue with the session. So basically, I was saying that 2020 has been a quite interesting year for space, and actually we have reached the record in the highest number of satellites being launched in a year, with 1,200 satellites being launched only in 2020, which is amazing. No, it's an amazing number. So I pretty like a lot this sentence of Dylan Taylor, which says everyone is in the space industry. They just don't know it yet, no? So, okay. Then if we have a look, okay, let's say, okay, so 80% of the satellites which are being launched today are actually nanosatellites. And then if you can see in this graph, in this slide, that here I pin basically the number of nanosatellites which have been launched during the last 20 years, okay? So what you can see, for instance, the green line that goes below all the other ones are the number of nanosatellites which actually carried some kind of onboard propulsion. And this number is very low. You can see there is a huge gap between the number of total satellites being launched and the number of total nanosatellites, which actually includes some propulsion system. So why? Because we have seen in the previous slides that propulsion system is absolutely critical, and it increases your functionalities of any platform. No, why people like customers like building nanosatellites don't include propulsion systems? Oops, sorry, here it is. And actually the number is quite worrying. Like if you have a look, you can see, for instance, in this slide that every satellite with a mass above the 10 kilograms will carry 70 or 90% of them will carry onboard propulsion. Okay, but in the nanosatellite sector, only 6% are adopting this onboard propulsion. So why is that? Why is this? No? At ienai Space, we have identified that well, there is a huge problem in the market now with the onboard propulsion, and the reason is simple. Okay, imagine in this graph, for instance, like we have a plot at the left. You can see a plot of all the technologies which are available. So imagine you are a customer, you have a platform, and you want to buy a propulsion system. No, what you can see here, for instance, all the technologies available in terms of what we know as the specific impulse and the thrust to power ratio. This I won't go into a lot of technical details. You will need to study some rocket science to properly understand this, but basically you can see the specific impulse, which is the vertical land. This is the exhaust velocity of the propellant with respect to the spacecraft. So the key here is that basically if you are a customer, you could go, as I was saying, for electric propulsion or for chemical propulsion. Okay, so if you go here, the key is that since with electric propulsion you can achieve much higher exhaust velocities, you are going to have an exponential reduce in the total propellant mass that you need to carry. And this is critical, and this is critical for small satellites. Okay, but what we have identified at ienai Space in my company is that actually there are 3 red lines nowadays that are limiting these adoption rates of electric propulsion in nanosatellites. And these 3 lines, as you can see here, are basically the first one and most important one: the limitation of power. Like these small platforms, they have normally less than 10 watts available for the propulsion system, which is very, 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 very few. Then not only you have very low power to operate your thruster, but also all the propulsion systems that are out there in the market, they are very, very low. They have very low efficiencies at low powers. This is because they are normally based on plasma devices. We could have another talk about this, like in another moment, because but you can ask me also at the end of the presentation. But the thing is that they are very, very low efficient. Actually, if you have a whole thruster, for instance, with a 20% efficiency at 50 watts, it's already great. So the efficiency is very low. And finally, these technologies are normally optimized for specific operation points. What means this is basically that our clients need to choose the propulsion system, need to select the propulsion system in a portfolio of products, which is not the best way to sell propulsion. So what are we doing at ienai Space? And at ienai Space, we are developing what we say the next generation of propulsion, which is based on electrosprise. Electrosprise it's electric propulsion, but it's not based on plasmas. We just accelerate an ionic liquid, which has quite a lot of advantages. Since we don't have pressurized deposits, these liquids are stable in vacuum. We can have passive feeding, etc. We also have only electrostatic acceleration, so we don't require any magnetic elements. And the most important thing is that we are achieving efficiencies higher than 60%, which is the best, the highest efficiencies in the market currently. No? Here you can see, for instance, one of our first breadboard models. You can see in the picture. You can see this thruster, which is actually the size of this thruster is 2 × 2 centimeters. Like you can imagine, like it's really, 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 really small. No, this thruster, our thruster is called Athena, adaptable thruster based on electrospray for nanosatellites, and is as you can see also in the picture, is completely modular and scalable. It has a variable specific impulse. Again, this is quite technical, but it's basically we can have a variation in the performances of the thruster with this system efficiency larger than 60% and a very low power consumption. And one of the most interesting things also, and our key differentiator, is that we say that our thrusters are basically software-defined electric thrusters. Okay, and in order to explain this, I will say that it's the same as saying like they are mission tailored for optimal performance. No, this means that we are basically designing the thruster taking into account both your requirements of both your platform and your mission analysis. Let me go to the next slide so I can explain this better. So when we say we're providing tailored propulsion solutions, we are aiming to say that basically through our website that is going to be launched hopefully the next month, you could have access to our own software, which is called ienai Go. And in our software, you will be able to select, okay, what kind of platform do I have? Imagine I have a 3-unit CubeSat. What kind of, how much power I'm going to have available? Obviously, depends on the number of solar panels that you're going to deploy. What do you want to do with the satellite? I want to do run phasing. I want to do orbit racing. I want to do deorbiting, whatever. And then our software would say, okay, this is the propulsion system that you should carry. Exactly the propulsion system with the optimized solutions and with the exact amount of propellant. This is completely new in the market, and we believe it's going to disrupt completely the way people are buying propulsion systems, because we are doing it the other way around. Currently, let's say there are some types of propulsion systems available, and the customers choose the propulsion system that better fits into their platform. We are doing it the other way around. Okay, no. Tell me, what platform do you have? What do you want to do with your platform? And I will design and build and sell to you the best propulsion system that you could carry. No, this is just an example as how our ienai Go software will look like. So imagine like here you have a 3-unit CubeSat. Okay, I want to do in the launcher here will leave us at 357 kilometers. Then I want to do, for instance, run facing. I want to do 90 degrees, and it will establish like a 150 maximum, let's say maximum duration, 150 days of maximum duration. No? We calculate the maneuver, and our own software will directly say, okay, if you want to do these maneuvers with this kind of platform, you need to carry this propulsion system. Okay, so this is kind of what we are doing at ienai Space. This is our team. So what we call as our rockstar team. So we started the company, we founded the company 2 years ago, the 3 co-founders, and currently we are 10 people. So we are quite proud of all of us. So and we expect also to grow the team during this year and during the following years. So please shoot us an email if you are interested in working with us. We are always open to new applications. And just before finishing, I would like to just mention that we are not alone in this new space race. Here in Spain, there are a lot of companies, quite a bunch of companies, which are actually working in the new space. These are just, let's say, these are the most known companies, or the ones that are more established at the moment. As you can see, very interesting that in Madrid, at least the 40% of these companies are located in Madrid. No? So Madrid is becoming really a reference for the new space. And one of the, let's say, philosophies also of new space is mainly collaboration and creating synergies between all the companies. So you can see here, maybe you have read in the media that we have made a consortium between 20 companies, Spanish companies, to build a 30 satellites constellation to precisely to provide Earth observation data. I'm sorry, I will end up with this now. It's now 1 minute. Also, we have created one of the, let's say, from all these 25 companies in Spain, 5 of us, we have created the first new space cluster in Madrid, which is named the Madrid Innovation and New Space Cluster. Here you can see some of the companies which integrate this consortium. Also, there are other companies that are also in the consortium that you cannot see here because they have been incorporated very soon, like Hydraspace, for instance, which I think Eduardo, the CEO of Hydraspace, is also here, and a few companies more. So our main goal of creating this consortium is basically, well, we say our guiding principles are these ones that you can see here: inspire, collaborate, converge, and compete. No? And set Madrid as a reference for new space, not only in Spain, but also in Europe, and why not, like internationally. So our first project that we are going to develop in the consortium in MINSC is Cibeles, Project Cibeles, which is an in-orbit demonstrator. We are planning an in-orbit demonstrator in 2022. We say de Madrid al cielo in Spanish, which is going to be literally that. So here you can see, for instance, how we're going to develop this CubeSat with the participation of all these companies, where they're going to apply their know-how to the development of this CubeSat. And I will also want to say, since maybe there are quite a lot of students in this chat, that we're going to make a competition which is named Fly Your Experiment in Cibeles, where you could propose scientific payloads that will be evaluated by a technical committee, and the winner of this competition will be allowed to fly his or her experiment in our satellite in Cibeles. So this is everything on my side. Thank you very much, and sorry for those 2 minutes. I'm over time. If you have any questions, it will be a pleasure to answer them.
Okay. Thank you very much, Sara. Very interesting project, both. Now it's time to find out more about Madrid Flight on Chip, a European research and innovation project funded by the Community of Madrid and the European Union. It is a consortium formed by SENER as the main partner, IMDEA Software, and the Carlos III University in the research part. Genera, Temptun, Reuse, and MAR are the rest of the partners. To learn about Madrid Flight on Chip, we have Victor Gil, main investigator of the project, and Santiago Lozano, software developer at SENER. Welcome. All yours.
Thank you very much. Can you hear me? I'm seeing I don't have the best internet connection right now.
Yes, yes. I hear you perfectly.
Okay. So I'll try to, I prefer to share my screen because there are some animations. So I'll try to share this screen. Okay. Okay, can you see it?
Yes. Yes.
Perfect.
Thank you.
So thank you very much. I'm Santiago Lozano. I'm one of the people who's going to talk to you about the Madrid Flight on Chip project. Our presentation is called Speeding Up the Design, Increasing Flexibility and Services, the Madrid Flight on Chip Perspective. So I'll start by giving a little bit of context. As many of you will know, the aerospace sector has always been characterized by needing high reliability and high determinism rates. And this causes, among other things, that the electronic components used in large satellites and classic space missions are usually out of date, at least when you compare them to the solutions offered in other sectors. So typically, robustness is given more importance than the power of the electronic components itself. As Sara said in her presentation, in recent years, we have seen the emergence of a new trend in the space sector, which is usually called new space, and is basically the emergence of a small market, a new market based on small satellites. As she said, it's kind of a democratization of the space sector. And at SENER, as a company with large experience in the most classic space sector, we thought it was a good time to stop and think about a new way of doing things and to develop a new way of developing space applications. Although I will go into details later, Madrid Flight on Chip is a project aimed at implementing a multi-purpose platform, a generic platform, from which new space applications can then be developed. So the first thing we needed to do in order to start the design of the platform was to do a trade-off between among the different technologies or the different solutions that are adopted nowadays in the space sector. Roughly speaking, we can distinguish three big types of processor systems. We have the traditional processor systems, in which usually there is a single processor with one core and devoted companion chips for specific processing functions. The memory banks are external, and the communication interfaces are implemented on specific devices. As the name suggests, these are the processor systems you can find, or you can more commonly find in traditional space missions. It's robust, but it's kind out of date. There are also the multi-core solutions, in which it goes one step further, and typically there is a processor with several cores built to an FPGA. They still have external memory banks, both internal and external communication interfaces, and they still present some limitations. For example, the FPGA and the processor domains are separated usually, and the most common FPGAs in these solutions are non-reprogrammable. So once the FPGA is programmed, it cannot be reprogrammed. So it doesn't offer that much flexibility. Multiprocessor system on a chip, which is a concept I guess many of you will know. It's just basically joining all the electronic components that are part of a typical electronic system into one single chipset. So here the memory banks are included in the chip. There is usually a relevant quantity of random access memory available. The FPGAs can be reprogrammed, so that offers a lot of flexibility. And in short, as you probably anticipated, we believe that this is the technology that fits the most with the new space applications. This is just a slightly more detailed comparison between the characteristics of the MPSOC technology and some of the new space applications, the most typical space applications. As you can see, it fits very well with the philosophy of new space. So this is the context in which Madrid Flight on Chip was born. Madrid Flight on Chip is a project co-founded by the European Union and the Community of Madrid, and it's carried out by a consortium made of SENER, the University Carlos III of Madrid, and other public entities and medium and small-sized companies of the Community of Madrid. The long-term objective is to put the region in a privileged position in the design and development of small platforms and new space applications in general. The technical objective of the project, as I said earlier, is to design and develop a multi-purpose platform for new space applications, for the development of new space applications. It is a generic platform, so that any new space application can be developed from it or on top of it. So expressing it in a not very technical, but I guess quite illustrative way, we could say this is a kind of a skeleton for a space system, in which a large part of the functionality that you expect in a space system is already implemented in the platform, and only the specific functionality of each mission would have to be implemented on top of that. I would also like to say that this platform will also be tested using some real new space use cases. The consortium itself tests the integration from third parties. One of the main advantages of the platform is that it offers these services that I just talked about, these services that you expect from any space platform, in the form of an API to an external developer, so that the external developer just have to know this API to develop an application on top of our platform. The idea is to follow the philosophy of mobile application development. A mobile application developer usually doesn't care about the specific device in which his application is going to run. So this is a similar idea. A developer for this platform could just have to know an API provided by the platform itself. And as the project is formed by a consortium of different companies, it is necessary to integrate parts of the project developed by different entities. So this is kind of a self-test of this integration philosophy. In short, thanks to the multi-processor system on a chip technology, our platform would offer higher performance at a lower cost, and would provide also higher flexibility. We'll see it in a minute in my last slide, but the architecture has a modular structure. We'll see it in a minute. But first, how did we do this? Well, starting from the real use cases that I just mentioned a couple of slides ago, we differentiated the functionality that was specific to each mission from the functionality that is common to or transversal to all space applications. So this common functionality can be implemented as a service of the platform. Also, we had to, from a very early phase of the project, we had to do a software hardware co-design to map these services between the FPGA and the software domains, because there are some functionality that will run better in software and some functionality that will run better in the FPGA. And moreover, it was really important that the solution obtained was hardware agnostic. So it can be migrated to a different platform in case it is necessary. For example, if there is some specific platform that becomes really important in the space sector, we can migrate our architecture to that hardware platform. Here is a list of high-level requirements and specifications that, well, just reinforces what I just said. The platform must be flexible and offer an API for external integration, with services mapped between the software and the hardware domain, including the FPGA. And this last slide is what I was telling you about before. Hopefully with this image, you can land everything that I'm saying. As you can see, the architecture has a modular structure in which in order to be as flexible as possible and be able to replace layers as easily as possible, the bottom layer is the hardware layer. It basically consists in all the hardware, including the processor and the FPGA. On top of that, we have the hypervisor, which is a key piece of the architecture. It provides time and space partitioning. And this basically means, well, in a typical space application or space system, you have parts of the system which are more critical and parts of the system which are not that critical. So it's very useful to be able to separate that into different virtual machines or partitions, so that the failure of a part of the system that is not very critical could not affect part of the system that it is very, very critical. On top of the hypervisor, we have an operating system. Each of the virtual machines can run an operating system, a different one, or even you can have partitions with no operating system. In case you have for example, some functionality that is really critical but quite simple. You could have a partition with no operating system. In case there is an operating system on top of that, you have a abstraction layer, which basically separates the top layers from the bottom layers, so that the services and application layers don't have to deal directly with the operating system. And if the operating systems need to be replaced, this can be done without any problem. On top of the abstraction layer, we have the services layer, which is what I was telling you about. This common functionality transversal to all space missions. So it doesn't have to be rewritten for each mission. And this is the layer that offers an API to the application layer, so that let's say the application developers can use this API in the application layer, which is the top layer, and is the layer in which mission-specific functionality is integrated and is developed. And with this, I think I'm going to leave you with my colleague Victor, who is going to talk to you about the work that it has been done at the University Carlos III of Madrid. Victor, I don't know if you prefer to share your own screen or you want me to continue with my sharing. I don't know if you are speaking, Victor, but if you are, you have.
Thank you, Santiago. I was mute, sorry. Okay, I will share my own screen. Thank you very much, okay. Santiago. So,
thank you.
I'm Victor Gil, and I will talk about the work at the university in this specific project. So basically, as Santiago said, we are in the new space. I mean, all of us here, we are interested on the new space. So let me first comparison between when probably 70 years ago or 80 years ago, we thought on a very high quality, robust, and very high standing vehicle. Probably we think on Rolls-Royce, okay? Probably we still think on Rolls-Royce. But 10 years ago, Elon Musk, they say, why rely only on very hardware vehicles and design or propose to create a new car, a new vehicle based on an electric one. You know that the electric car are more focused not only on the engine, which is also electric, but need a lot of software. Okay, so they create, and nowadays, if we think on high-standing, robust, and high-quality car, probably we also think on Tesla. It's the same. We can make the same comparison in satellites. Okay, the traditional satellites, they are relying on a very long time for designing, building, testing all the small pieces individually, and then put together. They have a lot of mass. I mean, we have recently listened to Sara that mass makes money in the space. Okay, so we try to reduce this mass also with this new propulsion proposal by ienai, but also we can reduce making everything in a single chip, as Santiago said. So the first question, say, okay, why not to convert these traditional satellites into more software-defined or more flexible satellites? Okay, probably most of you think, okay, because we don't trust on software. Okay, it's a very simple answer. Okay, imagine that we launch a satellite, we spend a lot of money, we spend a lot of time designing, and we launch it, and after a couple of weeks, a blue screen of the death, appears, and the mission is over, right? So we don't trust on software, but we think that we can design a software that we can trust on, because based on some redundancy, based on some supervisor, hypervisor, they talk Santiago about it. So we can design a system based on software, but very reliable, means that we can trust on this software. Okay, so this is the concept of MFOC, which is this project that still have some, let's say, hardware parts. It's like the Tesla. The Tesla also has the wheels, have the structure, has the seats, have many things that are hardware. But the core is software. Here is the same. We have a common platform, and we try to develop a system based on software that can be the platform, the meta platform for different applications. And in the future, why not? We can even reconfigure the satellite, even the satellite mission in the future on the Earth. So what to do? We need a lot of research and development and a lot of innovation. I mean, here I will put this. Okay, so to convert from this part of hardware to software, we need a lot of research. This is what we talk about in this project. Okay, so for doing that, we have a multidisciplinary team at the university. We have four different groups with 4 different, let's say, areas of knowledge. We have the aerospace group within the aerospace department at the university, and basically is in charge of the avionics and the system design, system modeling, space simulator. Okay. Also, we have the reuse group within the informatics department that makes basically are in charge on the embedded software in this system. Also, we have the communication group within the telecommunication department, and is in charge on the data link, okay, that the communication for this new space platform. And also we have the microelectronic design and application group within the electronic department, which are in charge on the hardening the system, robust, to make robust this system into a space application. So how to do it? Okay, the main goals at the university, we have many goals. Okay, so basically the first one is the avionic architecture. Okay, the definition of all of these avionic architectures, and also the embedded software. Okay, that we need to develop in this platform. Both of them, okay, have special characteristics. Okay, so the first one is that this avionic architecture and this embedded software has been never tried in a space application ever. I mean, it's the first time we are gonna to insert all of this in a single chip. Okay, so we need to change our brains, our mind, and the methodology. Okay, also this avionic architecture and embedded software need to be resistant to radiation. Okay, because I mean we know that the radiation is bad. I mean the space is very critical environment, so the scenario is one of the worst we have, because we have vibration, we have high temperature, low temperature, we have this variation of temperature, we have radiation, we have many things, and we also have the constraint on mass, on power consumption, on temperature. Okay, so for doing all of this, they I mean, we focus on new methodology, which is the model-based system engineering methodology. That basically we will talk in a minute on this methodology. Okay. So for this point, we will use the model-based system engineering. Also, we have the space simulator for this specific mission. Also, we need to design and implement on an RF SoC. I mean, Santiago talked about the MPEP SoC, which is the multiprocessor system on chip. But for this specific application, we also need to communicate. So we have the, let's say, a kind of MPEP SoC, which is called radio frequency system on chip, that apart from all of these element that Santiago introduces, also includes some radio frequency part. I mean, some very generic radio frequency part that we need to somehow program and reconfigure to be able to transmit and receive data. Also, we have an use case, very interesting, which is the design and hybrid beamforming for satellite. It has been never tried, and it's very expensive in a traditional designing way. It's very expensive to try to test or to check if it's working or not. Beamforming. Beamforming we have in mobile communication and it's working perfectly, but we don't know if it in satellite will work or not. But it's very expensive and it takes a lot of time, effort, and money. Okay, so but with this new space application, with this new methodology, with this new paradigm of designing satellites, we can have, because we reduce this time of designing, we can have time enough just for design and test and hybrid beamforming and check if it's possible or not, if it's worth or not, okay? Because everything will be somehow in the same chip without too much hardware, okay? I mean, at the end, the antenna will need to be there, and SENER is working on this, so at least at the end we have some hardware, okay? Also, since we need to communicate hardware and software, we need to have some tests and proof that we have the hardware in the loop, means that we interconnect with the real hardware and we check our development. Okay, and finally, we need to robust the system. We need to protect the chip, every critical part. We need to identify the critical components on all this design, just to make redundancy on them, make more protection, and we have the hypervisor and the supervisor. Okay, so we need to make robust the system. So basically, what I say that for the current situation is we have many, let's say, we have a lot of documents for, let's say, for the specification of the system. We have some spreadsheets based on the different components, on different characteristics of the system. We have flow control design, project management. We also have some tools for the life cycle management, the traceability of the project. And then on the other side, we have the tools of the application where we implement the things. For instance, the databases, the Rhapsody, Magic Draw, Papyrus, that are system modeling and system designing tools, and also the simulation tools. Nowadays, they are independent, so we need to make relationships with the specification goes to the implementation, with the some characteristics based on spreadsheet, for instance, goes to the implementation. The model-based system engineering, what makes move the focus on the system design and system modeling. Okay, so and interconnect all these elements. I mean, not the pure doors or the pure Rhapsody, but a very functionally, let's say, part of the tool can be interconnecting this using this engineering studio. Okay, so basically we take all of these reports, characteristics, documentations, just to elaborate our avionic, for instance, scenario, architecture, or our software, embedded software. Okay, so then another thing that we need to do, we need to make difference to two different kind of software here in this project. We have the embedded software, the traditional software that, I mean, traditional, more or less traditional, that runs into a microprocessor or a microcontroller, in this case into a microprocessor. But also we have some other software, which is the hardware description. We have the FPGA. The FPGA is a device where we have a lot of transistors that we can program, we can describe what we want to do, okay? And we can even program it on the Earth. So we can launch a mission and we can even reprogram all these things. obviously, the FPGA modules are faster than the microprocessor. So we need to identify which part of the project or which part of this, let's say, meta platform goes into the FPGA and which one goes into the microprocessor. Basically, all the communication part goes into the FPGA, because we need a very real-time, very high data rates. So when we do that, we need to identify, the way of converting something that before was an element of several elements, the modulator, the filtering, the radio frequency transmitter, the oscillator. There are many different elements. Now we are going to be described in an FPGA. Okay, so we need to clearly indicate all the algorithms, divide the algorithms in different blocks, and even different blocks with specific signals, the buffers, the size of the buffers, and everything, just to identify each of the algorithms just to be implemented or describing in hardware. Also, we need to simulate and say, okay, everything is working, so we can have the system working properly in a simulation. Why we need to simulate? Because before the implementation, we need to analyze what's happened in a fixed point implementation. Because, okay, when we make a simulation in MATLAB or in Octave or in other simulation program, we have infinity resolution. So our items works with infinity resolution. This is quite simple in this case. But what happened that when we are implementing, we are describing hardware, if we use infinity precision, makes that our hardware, our description of this hardware is very slow. It's very slow. So we can't use that. So we need to reduce the number of bits we need to use. So we need to analyze what happened in the fixed point. So we simulate and we then convert into a fixed point and optimize the number of bits on each algorithms or even on each part of the algorithms. So we need to reduce as much as possible, maintaining the performance. Okay, so then we need to, let's say, check that even with the fixed point evaluation, we obtain the good results, and then we need to go to the hardware description. We need to take any of the blocks we have and convert into a very simple operation that we can describe specifically in the hardware using our this let's say this VHDL or something code. Okay, so at the end we have, for instance, a filter, a specific filter. We have some signals that this is the input signal that we have reduced the number of bits because we need to sample the input signal, and then we need to filter and obtain something that that create a real signal with good performance. So we need to optimize every part of the design, and on top of that, we need finally, once we have designed the specific models or modules or even the whole system, we need to go and robust the system, which basically is identify, okay, this part is critical, and if something happens in this module or in this part, the rest of the system fails. So we need to make redundancy or makes an hypervisor doing this, or makes that this move to a different part of the circuits. So we need to basically be very compact in our designing, because once we need to we do the robustness of the system, probably we need to increase 3 or 4 times the size of this implementation. Okay, because of this, because we need to make sure that everything we are doing by software is fine. I mean, is correct, because otherwise we will crash on the. I mean, the system will fail on the earth. So the main conclusion in this squad, I mean, all of us, we are in the new space, so probably we know that the novel design paradigms for communication satellite is possible. I mean, we are developing the project. The project is more or less 1.5 years almost finished, but we have good results so far. We need more research, obviously. And we think that is a game-changing technology because it allows us to design, or even in the future, we redesign in orbit the satellite. We can include new, let's say, functionality, or we can change because something happened. Okay, so we think it's a game-changing technology, and we have also an unexpected result due to the pandemic. Okay, because when the pandemic happens and the blackout, we need to go everyone at home. So what happened in a traditional design of a satellite? The satellite will stop because we can't go to our offices, to our labs just to work. Since this new design is more relying on software, we was able to put the laboratory in remote, and we can continue working. I mean, the speed could be at the beginning was a little bit delayed, but then we speed it again. So I think this is my final slide. So thank you very much for your attention, and I don't know if you have questions. We can both Santiago, Sara, and myself ask the questions.
Thank you to all three for your talks, Sara, Victor, and Santiago. If someone has questions for them, you can write it in the chat, and we will tell them. Meanwhile, I'm going to ask a question. How relevant is to have a strong Europe in these enabling technologies?
Sara, would you like to start? Or?
Don't.
Okay, I don't know if
Victor.
Okay, I can answer. I can. Okay, I mean, so you mean that having a strong actor, right?
Sorry.
You mean to have a strong actor in the space in Spain, right? This is your question.
Yes. How important or relevant is to have a strong Europe in these enabled technologies? How relevant?
I think the companies. I mean, since I at academia, I think it's better to be answered by the companies.
Yes, sorry, I can take this one, Victor. I was not able to answer because I was not a presenter, so I was trying to. Now it's solved, so I can answer. I can answer the question. So I think it's not. It's absolutely relevant. Like it's obviously. I mean, we need to have. And particularly in Spain. Saying like there are so many companies that now are being also in this new space sector, no? that are being created, that are being funded. I think it's absolutely crucial for a country and obviously for Europe to have these technologies in house, because nowadays we all have to extrapolate, no? We have to get there are a lot of there are still a lot of technologies that we cannot let's say that we don't have them in house. But I think we have exceptional researchers here in Spain. The science is really good, and we need to do a better, let's say, technology transfer. I think we need to work in this direction, because Spain is going to be, I think, I believe, and I completely believe 100% that we have a very good scientists in this country, and we just need to give them a push and give them and improve the technology.
Okay, thank you, Sara.
I'm
okay,
sorry, I cannot participate that actively in this conversation because, as you can see in the panel, my connection is awful. But I just want to add that in a market that is still in an early stage of development as new space, I think it is especially important to get ahead and develop these technologies now, as Sara was saying. Just wanted to say that.
Okay, okay, thank you, Santiago. Okay, thank you for three, and it's time to welcome the next speaker. Now the time has come to learn more about ONDA DIAS, one of the 5 DIAS platforms that facilitates access to data from the Sentinel satellites of the Copernicus program. Franck Ranera, Earth observation data expert at Serco, will be the one who will give us more details about this platform. Welcome, Franck. Are you here? Franck?
Hello, can you hear me? I see
Yes,
now that
yes.
my camera and everything was mute. So I try to open all this stuff so you can put a face on my name. I hope it's working.
Yes, I see you. I see you.
Okay, so
Okay.
hello everybody, and happy to be with you.
Thank you.
I will try to share my screen then. I will stop my video just to avoid having any problem of connection. And share my screen. Share files. Well, wait a second, just trying to find it. It seems I need to add it. Okay. Did you have any presentation from the DIAS already? I can even start talking. So just about the concept of the DIAS has been developed by the European Commission, let's say 4 years ago. And it aims to deal with this situation where we have a lot of data available, and the difficulty of the people to access this data and to process this data. So basically, they tried to give a kind of framework and tools to allow people exploiting this data. So just 1 second, I'm just dropping my file.
Franck, we don't see your presence. Franck, can you hear me?
I think maybe Franck has a stolen connection. I don't know, but he tried to reconnect.
Okay, we are waiting 5 minutes. Sorry. Franck, can you hear me? I think Franck. Let's wait 5 minutes to see if we can get the connection back with Franck.
Hello?
Hello, Franck, can you hear me?
Yeah, I can.
Okay. We can't see your slide.
Yeah, I tried to upload.
Okay. Yes.
You should see that now. Is it as easy like that?
Yes, yes.
Okay, just to understand how to move the slides. Perfect. So here we are. I have 20 minutes, right? Can you hear me?
Yes,
right.
yes, 20 minutes.
Okay, well, I will try to do that in that time. So as I was explaining you, the concept of the DIAS came from this huge amount of data that we have today, the satellite data, but DIAS stands for Data and Information Access Services. So it is a program that has been opened by the European Commission. It is an industrial contract that the European Space Agency is managing, and they pass it through the industry. And Serco is leading one of these digital platform. It bridges, let's say, the huge amount of data that the Copernicus Sentinel data are acquiring, and the cloud-based infrastructure to process this data. Basically, it gives you multi-petabyte of data and the virtual computer to process this data. You don't need to have your computer under the desk. You have it in the cloud, and you can scale it according to your need. More RAM, more CPU, more storage, or less of everything. And you can play with that according to your needs. Copernicus, is important to mention, it has been a real game changer in the world of the satellite data, Earth observation, because the satellite that belongs to the European Commission, the Sentinel data, acquire systematically when they fly over land, let's say not worldwide, but globally speaking, yes, and Europe is systematically, each time the satellite or the satellites, because it's more than one, are flying over Europe, they are acquiring. And it's free. All this data are for free. So this has been a huge game changer with respect to the other data providers in the world. I'm not just talking about Europe, I'm talking about the US, Asia. So that's the philosophy of Copernicus. Give the data for free to people, give the means to exploit this data, not for free, that's the cloud, but I will come back to that, and open application. Just need to click on that. Next slide. So we are talking about data. This slide just gives you the information. So if you're familiar with the Copernicus world, you will know what is Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-5P. These are constellations of satellites. Each one has its own specificities. Sentinel-1 is SAR data, what we call radar. Sentinel-2 is optical, let's say a 10-meter resolution. Sentinel-3 is also optical, but a lower resolution, but covering a huge space on the world. Sentinel-5P is more dedicated for atmosphere. And this sat is also a European satellite launched in 2002, and it's not working anymore, but we have a lot of archive data, so which is quite important if you want to build some time series monitoring trends. Okay, for instance, stream, temperature, or whatever linked to that is changing, that is dynamic. Landsat 8 as well is a satellite that belongs to the US, but I have also a huge archive because I think that's the first satellite launched in the 70s. So you can imagine the amount of data that is available here. Again, for any dynamic analysis, it's quite important to have this huge data set. Copernicus is not only satellite, and it's also services. And I give here the example of 3 services where you can find the product that are produced by the services on ONDA. I mentioned here the land monitoring service, the marine environment monitoring service, the atmosphere. It means that when you access to the digital platform, it means that when you get a virtual computer, you already have all this data stored on your computer. And we are talking about more than 31.1 petabyte of data. It's a huge quantity. Just to give you an image that is quite meaningful, we receive every day the height of the Eiffel Tower of DVD stacked one on top of the other. That's the amount of data that is acquired every day by the Copernicus missions, and that we have to manage and to store and to disseminate to you, to all the users. We do offer as well, but I will come back on that, an area when you can store your own data. You know, the Earth observation world is composed by many, many satellite data, but also drone or any what we call third-party data. And we do propose an area where you can store this data, a secure area, because some of them can be sensitive or license protected. Not everybody should access to this data, but it's your own property. But what I want to pass as a message here is that through the platform, you have your environment with all the data. 31.1 petabytes of data are already stored there, and you can put your own also in the same place. This means that with your computer and the tool that you use, you can access all this data without downloading anything. I need to click on that, right? But in ONDA, we understood that we should not stop to the Copernicus data because they have specificities, spatial resolution, spectral resolution. And we understand that many of our customers, they may start an application, a commercial service on this data, but if they want to extend your capabilities, then they will need to focus other data type. This data type, what we call the very high resolution VHR satellite images. I was talking before to data that have 10-meter resolution at best, optical data. Here we are talking about data that are 30 centimeter spatial resolution. You have the possibility on this data to separate two elements that are of a distance of 30 centimeters. And we do that not because we own this data, we do not own this data, but we sign partnerships with this data provider, Deimos, Maxar, ComSat. This means that through ONDA, you can access to this data. They are not already stored on your local computer, I mean your virtual computer, but you can access to this data, you can ask for this data, and they can be directly uploaded on your virtual machine. But even better to that is what I mentioned here, the digital libraries. In the world of the cloud, you know, we are all very often talking about APIs. And that's what we had with this, with Maxar above all. You have the possibility to access the data using APIs. This means to upgrade your algorithms to automatically search, identify, either download or not download, but process the data you have identified. We do that thanks to these digital libraries. So with ONDA, you have the panel of Sentinel, Copernicus data, Copernicus core services, products, 31.1 petabytes. You have the possibility to upload your own data. Sorry? Well, I continue. I think someone wanted to say something. But then you have the possibility to access as well very high resolution data. That's, I would say, the data pillar. Let's talk about the other pillar, which is the cloud. So here we are a consortium. And our consortium is with our cloud provider, which is OVH, which is a French cloud provider, and is proposing a huge quantity of virtual machines. We group them in categories that you can see here. You have the general purposes. That is a good ratio, a good balance in between the CPU and the RAM, generally used for front-end server. You have the CPU. This means machines that are give the emphasis on the computing power, and this is really well suited for machine learning activities. And we are talking about artificial intelligence, and a huge quantity of data that need to be processed very fast are needed. Then we have the RAM, or let's say the computer that need to have intensive memory, and this generally is well suited for activities that coordinate databases. So here, a customer can select whatever he wants. We are not talking about one single virtual machine, one single computer. We are talking about a range of virtual computers that have specific specification. You can see the number of core, the memory, or the storage on the left-hand side. So this is all the machine, the virtual machine that you can access. Obviously, we propose something more as well. The GPU is very well suited for the machine learning, the deep learning, the artificial intelligence algorithms or services. We do have as well all the virtual machine I'm talking about here have already a disk on it. But we do propose as well additional disk. You can see block storage, object storage, These are all elements that can be added and that will increase the capacity you will have to store the data you need. And again, all these storage capacity are accessible via APIs. That's quite important because that's the way the cloud is working. The link between the data and the virtual machine is through these APIs. This is the language they use, okay, to access the data. By the way, just a quick example. Well, not so much an example, but when you access to your environment, the digital platform, then you have various options. Either you can use the portal and select yourself the type of virtual machine that you need. You select your operating system, can be Linux, can be Windows. When you set the instance type, it is the type of virtual machine I was talking about, which is composed by a certain number of core of CPU, a certain number of RAM, a certain number of storage. And then it's like if you're buying a virtual machine, if you're buying a computer. What is interesting that you can stop it, change it, increase it, remove it, and you pay just what you consume. You will not pay something more than that. And we do give, as you can see on the left, on the right-hand side here, this is an interface that you can get, and you have full autonomy. Many of our customers are using that. Just by the virtual machine using this interface. Accessing this interface is for free. Then you select the virtual machine that you need. You can see some numbers here and some models, and then you run it. And again, remember, you pay what you consume. That's the philosophy of the cloud. Don't pay in advance for a virtual machine. At the end of the month, we look what you have consumed, and we invoice you according to that. So remember as well that all the virtual machines we are talking about are already pre-configured with software. The software are generally image analysis, image processing software. Snap, QGIS are commonly known, but many others can be installed. The philosophy again is free and open. What is free and open can be pre-installed. If you do have a software, ARIS, PCI, that are well known as well to process satellite images, you can install on your virtual machine. Just have to take care that the license is compliant with the operating system, Linux, Windows. That's the only element. Then you will never be alone. When you have this environment of ONDA, you have the FAQ or the user guide that give you all the procedure step by step to start with us, to work with us, to use the APIs, to use the catalog, and so on. But we do even better because we understood that it's not just as easy as that. Above all, if you start with this technology, this environment. So we have developed video tutorials that we share with our customer or registered users, showing them how to use the catalog in a step-by-step approach, showing them how easy it is to access the 31.1 petabytes of data and to look for the data that you need, how easy it is to run a virtual machine and the software. By the way, the background that you can see here is basically the background of your, or the display of your screen when you have the virtual machine. And you see you already have Jupyter Notebook, Snap, QGIS at the install. And just double clicking on the icon will open the tool. It's what we show in this application, Snap video tutorials, but not just how to open it, but how to access the product, to open the product, and to already first operation of band combination, just to see the product. And we do combine all these three approach in a Jupyter Notebook. Also, it is a video tutorial that one can access and see how easy it is to just in a few lines of code to get access to the ONDA catalog, to search, identify the product, either download or process the data without downloading it. That's a video tutorial that we propose just to raise the confidence of our customer, of our users in using our services. There is another one that we developed also, and this is, we call it ONDA for Education. Well, ONDA for Education is a service that uses the data and the virtual machine that I just presented now. It is basically built in relationship with universities, and they identify a thematic, and you can see on the right-hand side some examples of thematics that we already applied. And we prepare a course, a class with a teacher. It can be 1 month preparation, 1 week preparation. It really depends the area, the thematic, the number of data, all these elements. And then we run it. But we run it on the virtual machine that the student will get. So they can see how easy it is to apply that to generate an information. And by the way, if you're interested, you can copy this link, this YouTube link, because in, I think it's written here in May 6, 2020, during the lockdown, we generated a webinar, a free webinar accessible to all, showing how easy it is to generate this air pollution map from Sentinel-5P, just using the virtual computer and using Sentinel-5P data using Snap. So I will even say that you don't need ONDA virtual machine to do that, because the data are for free and you can download them. Snap is for free and you can download it. You can install it on your own computer. So it's just to show people how easy it is to process this type of, or to generate this type of information. I think I have some additional slide. I will pass very quickly on that. So CleoP is a set of Jupyter notebook, again, that show how easy it is to develop an application using this very dynamic approach of the Jupyter notebook. Is today becoming quite obvious that many people are using it. So we have developed here some examples, and we give access to our customer to use it. Basically, behind the Jupyter notebook is the infrastructure and the data I talked about before. I will pass very quickly on these ones as well, because I want to give you some examples of application then. Most is quite important just for you to know it. When we are talking to cloud today, we are facing 2 elements. A big issue, let's say, a big challenge more than an issue, is the storage. The storage is becoming an issue. If you have to store every day the height of the Eiffel Tower on your living room of DVD, I'm talking about, that's quite complex. So it's what we are facing. So we find a way putting the data on what we call the cloud archive. But the impact of the cloud archive is that it's adding delay in giving you the data. So we created these services that we call MOST, because we don't want our customer to suffer any delay. So we are creating them an environment where they can get access and immediate access to the data wherever the data is stored. That's what this services is dedicated to. And it's responding to some words that you may have heard today: Destination Earth, Digital Twin Earth. These are flagship programs of the European Commission and the European Space Agency. These are projects with the aims to simulate the Earth and to anticipate its evolution. To simulate the Earth in a digital manner, then we need a lot of data. So that's why we created these services. Again, an infrastructure that gives an immediate access to the data without suffering any delay or performance issue. But let's go now. Okay, what's next? Yes, ONDA is not just a contract. As I told you, many of the elements I presented today are on top of the contract. It's not required by the European Commission. It's not required by the European Space Agency. But because we are a commercial company, we see the market, we see our customer, we see what they are asking for, and we are responding to that. So actually, we do have other pipes or other elements where we make evolving the platform. Kubernetes is a real cloud-based element. It's like an orchestrator. It's like a software that is able to see the amount of work you are doing, and it can automatically optimize the infrastructure that you need, and you will do it for yourself. So that's something that we will propose soon in ONDA. Analytics, and I will present you some analytics now. We do not make analytics in ONDA. We give the tools to our customer, to you, to everybody, to develop their own application. But today we are building partnerships with some of our customers to propose some solution through the platform. And I will present you that right now. VHR, I just mentioned the very high resolution data. We are discussing with some other provider to move from, I give you data and you pay for data. The data is generally 10 per 10 kilometer and 100 square kilometer, and you have to pay for that, whatever the area you are working. If you're working on 1 square kilometer, you need to pay for 100 square kilometer. Well, we try to move that and to change this philosophy and to move it to the cloud philosophy, pay what you consume. So the idea will be with some of these data provider to give you a possibility to just pay the square kilometer that you use. Don't pay for more than that. We're working on that for the future, close future. So some examples now, and that will end my slide. I have three slides more maybe. I want to give you some examples of applications that have been developed under ONDA. I will start with a very small company. It was a startup at the early stages, Agricolus. Now it is a SME. What they do is developing a precise farming application. So they give to farmers the possibility to monitor their fields, optimize their production by seeing how the field is today operated. In some area is working well, in some other area is not working well. So they can not only see it, but also simulate it in the future if they apply some measure that the system developed by Agricolus is the advice that the system is giving. They use satellite data, drone, meteorological data, in situ measurements, chemical composition of the field, many elements combined together to then generate various types of information. What they take from us or what they buy from us is, first of all, the Sentinel-2 and Sentinel-1 data, but also the computing power to run artificial intelligence algorithms that combine all this information. And their service is available through tablet, cellular phone, computer. So you see here, we are really talking about a small company that grew with us and then that developed these services for their customer. SME. Next one, Earth Surface Deformation Monitoring System. That's a research center. So what they do is measuring the ground velocity at continental scale. Measuring ground motion is not an innovation service, something that exists since years, but doing it on a continental scale in a very small time frame, we're talking about a month, that was the challenge, and they did it. And they did it at a very low cost as well. And that's thanks to the DIAS, or the ONDA capabilities. Again, they buy from us the Sentinel-1 data, and then the GPU. So here we need a strong, a powerful computing capacity to process this data. And what is interesting, they made a comparative market analysis. You know, if they are buying this system on others, well, they see that it's quite cost efficient and competitive to pass through a DIAS or to ONDA than going to other cloud providers. So another example, COVID-19. We are all living in this context since a month now, and we are participating with some customer, one of them, to some project that aims to measure the impact of the policy to fight against the COVID. And you can see here one example of the situation during the lockdown and the situation after the lockdown or before the lockdown. And they do that by identifying targets in some places. They are developing a lot of services, but I wanted to show this one because it's quite meaningful. They apply automatic recognition algorithms to count the number of cars on some specific places. And they derive what they call the mobility index. There was something they did again in May, April, just after when the post-lockdown measures were effective. And actually, they are developing other services with some specific health authorities in their area to, again, try to help them to better organize their fight against this pandemic. Another example is the oil trading monitoring system that one of our customers developed. Here is combining a lot of different types of information, satellite, but also what we call the AIS, which is the identity of the ship. Now that is checking the oil from one place and to bring it to another place. And thanks to the satellite, they measure the quantity of oil the ships has taken, and the quantity is putting in another place. I will back to the other slide. I don't want to consume too much time. Real estate asset management service is also quite interesting because, again, it was a startup that now becomes a SME, and they are measuring the occupation of property from some big customer, I would say. That's quite interesting because this customer is the Vatican. ONDA is in Italy, as you know. We have no connection at all with the Vatican, but this company, yes. And the Vatican asked them to check their property first in Italy, but then worldwide. And these people were thinking to do that, driving and visiting the cities where the Vatican have some property, but they discovered that they have really a lot of property, and they cannot do that by driving. So they use space. They started to use space with us, and actually now they have developed a service which is identifying the property, but also saying to Vatican whether there is a change in a date to another over their property. And if the Vatican is interested in, they can even go to what we call the intelligence analysis using VHR data. Then I will conclude with this UN Agency's Critical Situational Awareness Service. Actually, we have various services that are both used or sold to the UN agencies. This one is dealing with emergency preparedness and recovery. Basically, when a disaster occurred in Southeast Asia, they ask for not only a situational awareness, because we're not really dealing with emergency or with reactivity, but how the situation was before and how the situation is recovering from the disaster to a nominal situation. And they are accessing this information through a web interface like this one that is using Sentinel-1 and Sentinel-2 data, and GPU as well, because they are combining a lot of information and they need to produce the information quite quickly, even if we are not in an emergency phase. Anyhow, they cannot wait more than 1 week to get the information. So this is another type of application that rely on the data that we have, the computing power that we offer, and the services that we built together. Oh, okay. This one was just what I was saying before with respect to the air quality map now that we did during the COVID. You can see that you can do it at continental scale worldwide, but even you can focus on some countries. And again, click on the link or go to this link and you will have an information how you can do that using the ONDA virtual machine. And we do offer to all these persons, to all our customers, a place where they can promote the service they are doing. If they are a startup or SME, that's quite important for them to be known. So it's good for us to show to the European Commission ESA how ONDA DIAS is used, but it's good for them that they can promote their services. When they publish something on our ONDA portal, on our portal, then all the registered users are informed. Today, we have more than almost 3,000 registered users, and many times below one mail, it's not just one person, but it is a distribution list. So many persons are informed about what they are doing. That's all what I wanted to show you. So I give you a quite comprehensive overview of what ONDA is doing. There's a lot of information in few times. So if you have any question, I'm free and happy to answer.
Thank you very much, Franck. Now let's move on to the first training session on CREODIAS with Klaudia Bielińska, Earth Observation Data Expert at CloudFerro, and we will learn success case with Professor Stanislav Lewinsky. The training session lasts until 7 p.m. Then we learn more about space enabling technologies, in this case, about how data can be used to build smart cities. Now is the time for training session on CREODIAS. Welcome, Klaudia. Klaudia, are you there?
Hi, hello, good morning, good afternoon, actually.
Good afternoon, welcome.
Thank you very much for the introduction. So I will share my screen to show you my presentation. Okay. Okay, I have some problems, I see. Okay, but can you see?
Yes.
You see presentation?
Yes, I'm seeing your screen.
Okay, but can you see my presentation, CREODIAS Earth observation?
No.
No. Okay. Okay, I see. It might be problematic. Okay, once again, I would try.
Klaudia, probably you have your presentation in another screen because we can see your screen, but not your presentation.
Yes. Okay, I'm trying to upload my presentation.
Okay, perfect.
Yes, but it's a bit messy, as you can see now.
No problem.
Okay, I see that few more minutes probably. Okay. I'm not sure if it's okay now.
No.
No. Okay.
Yeah.
Maybe now.
Okay. Now it's okay.
Okay. Okay, great. Okay, so again, thank you very much for the invitation for this hackathon. It's pleased to be here. Okay. I have again problem. Okay. No. Yes, maybe now. Okay, so yes, pleased to be here and to speak about our CREODIAS platform. So the agenda for my training session, it will be more like a workshop demo session, and I hope that 1 hour will be enough, but I have actually lots to say. So first of all, I would like to introduce myself and the company. Then I would like to give you a brief introduction to CREODIAS platform. Then I would like to show you the platform, the tools you can use. Maybe we'll have time for questions. And at the end, I will actually would like to spend some time for CREODIAS use case. So S2GLC project. It will be presented by Professor Stanisław Lewiński from Space Research Center. So you will see how CREODIAS can be used by you even for your projects. So CloudFerro company, who we are and what do we do? So CloudFerro company is a Polish company. We are based in Warsaw, so the capital city. We were established in 2015, so 6 years ago. So we work for Earth observation and space sector. So our company is quite big. We are all over 80 people here, engineers, specialists. Most of us are IT guys working on cloud technology, but also Earth observation specialists, product managers. Lots of people from IT and space sector. We can say that we are a leading cloud provider in Earth observation for Europe, and we are the biggest cloud provider in Poland. So what do? We build clouds. Here you can see the list, actually, but not the whole list, not the whole logos of our customers and partners. Most of the projects we do nowadays are for European Commission, are for European Space Agency, but we also work with EUMETSAT, ECMWF, and many universities. DLR, Polish Space Agency, Space Research Center, different organizations, different institutions, also with private companies, and also non-profit organization like Greenpeace. We actually do projects, European projects, but also international projects. For example, one of our project is based in United Emirates. So we are worldwide present. Our clouds are based in 7 different locations. Our clouds are in Reading, Frankfurt, Darmstadt, and of course in Warsaw. That's how our clouds look like. What is important that, for example, here in our office in Warsaw, we have a data center, but we have also a laboratory where we build our servers from the basics. So we have here our engineers who everything are doing on their own. And maybe I will take a chance to say that if you are looking for new challenges, maybe some of you, check our job opportunities because we are looking for cloud engineers and also Earth observation experts. We are also looking for people not based in Poland, not based in Warsaw, but also worldwide. So check the jobs and you can apply. So that was a brief story about CloudFerro, and now we will move to CREODIAS platform, Earth observation data and processing in the cloud. Thanks to Franck, you have already heard a lot about DIAS platform as ONDA is. So everything started with the European Commission and European Space Agency and Copernicus program. So a couple of years ago, 5 DIASes were established. So CREODIAS, Mundi, ONDA, VKO, and SOBLO. So I think that all of the platforms has the same basics, and they are built for the Copernicus data sets for data access and data processing. We, CloudFerro, are actually operating 2 of these DIASes, so CREODIAS and also VKO DIAS. Yes, so CREODIAS is a cloud computing platform. Through our cloud, we are giving users space for data access and data processing. But I can say that CREODIAS was for Copernicus data, but you can process any data you like. For some of our customers, Earth observation data are just additional data sets which they are using for their work. And some of them are using only Earth observation data. So we have different groups of the users. Some of our users are not using cloud computing space, but they are only downloading the data from CREODIAS, and some of them are using cloud computing space and virtual machines for their everyday work. So whenever you need a really powerful computer and really big storage, and you need to process your data really fast, I think that cloud computing is one of the best solutions you can choose. So CREODIAS, how it works and how it looks like. So basically we have a CREODIAS platform, so our website, and we have tools which are available for everyone, so from the website. So it's EO Finder and EO Browser. I will show you those tools later on. And we have cloud space, let's say. So when you are a registered user, you can use Cloud Dashboard to create your virtual machines and to use our space in the cloud. So CREODIAS is a public cloud computing, but if you need your private cloud, we can also establish that kind of space. And also we can establish hybrid. So it's a mix of public and private cloud. So what we have here, We have compute, we have Earth observation data processing, block storage, object storage, virtual networking, and backup. So all of the elements are connected with each other, and we can say they talk with each other. So all of the processes are seemingly connected. I think that a really important issue is that our technology, the CREODIAS platform, is based on open source. So we are working on OpenStack, Ceph, Kubernetes, so the technology open for everyone. But we see that it's a really powerful technology. So I can say that we are fans of open source. What you need to know about CREODIAS. Access to Copernicus data is free. You can also access Sentinel data, Landsat data, and other collections. You can download the data locally to your computer for free, or you can use the data which are available online, let's say, through our tools. But there are also some paid services. If you want to use virtual machine, you have to pay for that. So you pay for hour, or you can establish with us fixed term contract. So you can pay monthly, half year, or annually. So for all of you who would like to test our platform, who would like to establish your own virtual machines, we provide you 150 euro free credits. So I think it's really enough to establish your virtual machine and to get some storage space and to see how CREODIAS platform works and if it's really feasible and usable for you, for your organization. So how CREODIAS looked in 2020, so CREODIAS in numbers. So we have over 6,000 registered CREODIAS users. The local available Earth observation data exceeded over 20 petabytes. So around 2 petabytes of the data are coming every day to our platform. So I think that those numbers says everything, that really CREODIAS is a working platform. And I think that really important thing is that all of the all of the processes which are going on CREODIAS are supported by our customer support, by our engineers. So whenever you have a problem with the virtual machines or with the data, with any process, you can get support from our supporters. So I said before about virtual machines. So on CREODIAS, you can choose different virtual machines. Basically, you can see that they have different cores, different RAM, and different storage. So this is really flexible, and this is available depending on your needs. So they have also access to Earth observation data, or they don't have the access to Earth observation data. So the list of all of the virtual machines and also the prices for the virtual machines you can access on the CREODIAS website. I will show you later on where you can find it. And for all of the GIS users, I have a very good information that we have also virtual machines with ArcGIS installed on it. So if you only have a license to ArcGIS, actually ArcGIS Pro, you can access it on a virtual machine. So you are not going to pay again for the license, but you will only pay for the access to virtual machine. And I think that it will be really usable to use ArcGIS on virtual machines to process different data and also big data. We have also dedicated servers, so you can see that they have a different number. Of course, Yes, I see the question about QGIS. Yes, QGIS is also installed on some of the virtual machines, but also you can install any software you like on the virtual machine. Okay, so dedicated servers, they have different cores and different RAM and storage. As you can see, those are actually huge virtual machines. What data are available on CREODIAS? First of all, Copernicus data. Sentinel data, Sentinel-1, 2, 3, and both levels, A and B. We have also raw data and pre-processed data, so those after the atmospheric correction. And those data are coming to the platform every day. I mean, like whenever the satellite is around. So all of the data are coming to CREODIAS. We have Sentinel-5P data, Landsat 7, Landsat 8, and VSAT and SMOS. And hopefully soon we will also get Sentinel-6 data. The other collections which are available are, of course, Copernicus services. So we have the atmospheric service, emergency, land, and marine. So you can access those services over S3 or NFS protocols on the virtual machines. Whenever you need to use for your projects, for your work, digital elevation models, they are also available online. So we have different products like MapZine, SRTM, Copernicus DEM, EUDEM. We have also data from JSON-3, so the ultimate satellite, and we have also data from S2GLC project. So S2GLC, it's a Sentinel-2 Global Land cover. So it's a thematic classification of land cover for the whole Europe. And this project was done by Space Research Center, and Professor Lewiński will tell you more about this project later on. CREODIAS gives also access to very high commercial data, very high resolution commercial data. Now you can see the data from Jimenez satellite, Kaseosat, and ComSat satellite. So here, if you need a better resolution for your project, high resolution of data, so here you have better resolution than Sentinel. So starting from 70 centimeters, sorry, 40 centimeters in panchromatic like ComSat, and the biggest one, it's 4 meters of Kaseosat. We are also talking with other data providers, so hopefully soon we'll also have other very high resolution commercial data sets. When talking about software available on CREODIAS, I have to highlight that on CREODIAS you can access Sen4CAP system. Sen4CAP is an open source system software, and it is dedicated to agriculture monitoring. So you can use the software for free, and you can perform different agriculture analysis based on Sentinel-1 data, Sentinel-2, and Landsat 8 data. So the data are available, software is available, so you can perform analysis to detect crops, to see crop changes, to see grassland moving, and to calculate different indexes, vegetation indexes. For more information, please visit CREODIAS. I will tell you where to find it later on. And I would like to also give you important information that if you are planning or if you are doing any projects based on cloud, you can apply for funding. So for example, OCRE, Open Clouds Research for Research Environments and Network of Resources. We are there. We are in OCRE, we are a provider of a cloud computing platform. So you can apply for credits to use CREODIAS for your project. Okay, so this would be all from the theory, and now we will move to practice. I will move to CREODIAS website. but let me see if I can do it. Okay, hopefully you can see CREODIAS. Can you tell me, please, if you can see CREODIAS platform?
Yes.
Okay,
Yes.
thank you very much. Okay, thank you. So this is CREODIAS platform, CREODIAS website, creodias.eu. So first of all, when you enter the website, you can see all of the necessary information about the platform. So our offer, tools, resources, data offer, third-party catalog, and news. We try, CloudFerro company, we try to give twice a month webinars about CREODIAS platform and cloud computing. So please follow news and attend our webinars. But from this point, I would like to show you the tools which are available for all of the users. You don't have to be registered to use, for example, EO browser, but if you would like to use EO Finder, so for finding and downloading the data, you have to be registered users. So at the website, to be registered, you have to click register and register yourself at the CREODIAS platform. If you are registered already, you have to log in. I will do it. So I can show you the full functionality of the tools. So we will first see EO browser. So from tools, I go to EO browser. So EO browser, as the name says, it's for browsing the data. So here we can browse the data from different satellites. We can indicate the cloud coverage. We can indicate the time range of the captured data, of the acquired data. So let's start from the data collection. I would like to find the data from Sentinel-2 level 2A. And here I can pan on the map and find the place of my interest, but I can also use the search window and search the place of my interest. So as we are, as our hosts of this hackathon are in Madrid, I would like to see the data from Madrid. So Madrid, Spain, and now we are in Madrid, Spain. So I think that all of you maybe already know what I would like to show. I would like to show you Madrid covered in snow and also Madrid without snow. So first of all, I would like to see as less clouds as possible on our imagery. So I will indicate here 10% of cloud covered, and I will choose the data from last year. So for example, I can indicate November and beginning of December. So then I click search and I can visualize the data which are found here. Okay, so here, for example, we have one of the data sets. Soon it will be uploaded. Okay, so this is Sentinel-2 dataset from Madrid from 19th of November. And here we have the list of possible visualizations. So first of all, we can see the dataset in true color. So it uses bands 4, 3, and 2. We can see classification map of this data set. We can see the imagery in false color, so near infrared is used, and the near infrared is really good for indicating vegetation. We can see false color visualization. We can see normalized different vegetation index, which is useful also to see the vegetation and the state of the vegetation, if it's healthy or not healthy. We can see also moisture index, SWIR index, NDVI, and the NDWI index, and also NDSI index. But I will move back to TrueColor. Okay, and here at the bottom, you could see that you can download the image. You can download the image. It will be downloaded as a JPEG, not as a full Sentinel data set with all of the bands, but only as a screen of this data set which you can see now. But I will make a pin on this imagery to my favorite item, and I will also now search for the dataset from Madrid, but when Madrid was covered in snow. I don't remember the exact day when the snow has started to cover Madrid, but let's see, for example, middle of December and January. Okay, I can see that it was already covered in snow. So I can pin this one. And now, as I go to my pins tab, I can compare these two imagery. So I click compare. So we have Madrid covered in snow and Madrid without snow. So now, when you move the opacity, you can see the differences between those two dates. You can also click here split and then move again, so it will be more visible if you would like to compare those two images. I think this is really a quick and nice tool to compare images. For example, when there are any catastrophes, some natural catastrophes like wildfires or earthquakes, and you can compare how the city, how the terrain looked like before and how it looked like after. This is very fast tool which can help you to do really on-fly analyze. Okay, so this is CREODIAS browser, and this is tool you can enter from the CREODIAS website. I will now move to the other tool, which is EOFinder. So from tools, we go to EOFinder. And EOFinder is more complex tool. This is tool where you can find the data and you can download the data to your computer. So for example, you are not a virtual machine user, not a cloud user, but you would like to process the data on your own computer. So you can find the data set and you can download this to your computer. And here we have more search criteria than in your browser. So first of all, we can indicate the place of our interest here. We can indicate the time when the place was observed, when the data were acquired, and also when the data were published. Let's try to find a place also maybe in Spain. Maybe Valencia could be a good one. We'll see what we can see here around. So I will indicate here the observed time. So I would like to see a nice picture, nice imagery of Valencia from August. So maybe from beginning of August and then maybe 1st of September. Then I would like to indicate cloud cover. Of course, the best would be as less clouds as possible. Then below, I have to indicate data collection. So I would like to see the data from Sentinel-2, but as you can see here, we have also the other collections. So all of the data sets available on CREODIAS, so Sentinel-1 and VSAT Landsat and also S2GLC classification, but I will now indicate Sentinel-2. Then we can indicate the processing level. So I will choose 2A. And then I can draw a polygon over the place of my interest. I can indicate the place by point selection. I can also upload polygon. So for example, let's say that we were working in some other software, QGIS, ArcGIS, and we have drawn a polygon over the place of our interest, and now we can upload it here. But I will draw a polygon over this area, and I will see if there are any nice data sets from this area. So now I click search. Okay, here we have the list of all of the criteria we indicated and the list of the results we received. Here you can see the cloud covered in percent. So for example, I will choose the one which has no cloud coverage. Okay, I see. Okay, that one is nice because here we can see also water. So we can click on the imagery, we can zoom it in. That's a preview of the data set. So if we like it, we can simply download it. So by clicking it here, the whole pack, like the whole Sentinel-2 data set of this area, this imagery, will be downloaded to our computer, and we can make a use of it in the software, and we can process it in the software we are using. So this is CREODIAS Finder, so for finding and for downloading the data. So these are the tools which are available for you, and you can use them whenever you want. So I will come back to CREODIAS platform, and now from this point I would like to show you how to create your virtual machine and how to access the data from virtual machine. So let's go from tools to Cloud Dashboard. So Cloud Dashboard is the environment when you can create your projects, where you can create your virtual machines, where you can check how many credits do you have, how many credits are left. So you can do everything what is connected to cloud environment. So first of all, we have to be logged in to the cloud environment, to the dashboard. So here we choose the authenticate profile. So we can use Keystone credentials or OpenID Connect. OpenID Connect, it means that this process will take our username and password from CREODIAS. So let's use this one. So we connect. Okay, so here this is an overview of what instances we have, how much of what amount of RAM is being used, how many floating IPs are used by us, security groups, volume storage. So everything what we have here, it's what it's available for us, and we can make a use of it. I will go to instance pane. So here you can see what virtual machines you have, what are the characteristics of those virtual machines, what do they have, when they were created, and if they are running or if they are not running. So I would like to show you now how to launch new instance. So how to create your virtual machine. So here we should click the launch instance. In the first window, we should indicate the details of our virtual machine. So first of all, the instance name. I will call it Go2Space. Then I will click next. So then we should indicate the boot source. So here from this drop-down menu, we have available boot sources. So image, instance snapshot, volume snapshot. So I will choose image. So I will have on my virtual machine image of the operating system. And then below you can see what images are already available, so you can make a use of it. So for example, we have Windows 2090 with ArcGIS installed. We have CentOS with Sen4Cap installed. We have OSGeo Live with TensorFlow, so machine learning. And we have Ubuntu with QGIS and other Windowses and other images of other operating systems. For the purpose of this session, I will choose Windows 2090. If I want to choose this image, I have to click the arrow on the right, so the image will be added to my virtual machine. Then I go next. Then in this window, in this pane, we can choose the flavor of our virtual machine. I always compare those flavors of virtual machines as the flavors of ice creams. We can have a big ice cream in the strawberry, for example, flavor. We can have a small ice cream in a chocolate flavor. So we can choose different flavors for our needs. And here is the same. We can choose different flavors of virtual machines for our needs. If we see this sign here, the exclamation mark, it means that this flavor cannot be used. But you can see that here are more and more of available flavors, so you can make a use of them. I will choose this one, so Earth Observation 2 large, so 82 gigabytes of RAM and 32 gigabytes of disk. I think it's enough for my purposes. Okay, I have added this by clicking the arrow, and then I go to the next pane. Here we choose networks. So the channels of the communications between computers, between virtual machines. So the private network will be one of the networks I will choose. But if I want to have also access to Earth observation data, which are available for free, so for those Copernicus datasets, I have to also indicate the network Earth observation data, so EO data. So I will also add this one. And then I click next. In this pane, we don't need to indicate anything, and then we will go to security groups. So by the default, one of the security groups is added here. But if we would like to access our virtual machine, our computer from anywhere, it has to have another security group. The security group which says allow ping SSH RDP, so remote desktop. I'm going to use remote desktop to connect to this virtual machine, so I'm going to add this security group to my virtual machine. Okay, so it's added. So now everything is done. So by only a few steps, we can create the virtual machine, and then I will click Launch Instance. We have to wait few seconds for the virtual machine until it's going to be ready. Okay, it's done. So our Go2Space virtual machine has been already launched, but then I have to go to console and create the password for my virtual machine. So from this drop-down menu on the right, I click console, and I'm going to be redirected to the console. This console can be used. No, it cannot be used actually to work on it. It's I think too difficult environment. I mean, not too difficult, but not very useful, not very user-friendly environment. I think it's better to use other software to access virtual machine. But we access this virtual machine only to configure some basic things of our virtual machine, like the password. We have to wait a couple of seconds or minutes to be connected with the virtual machine. It's getting ready. I hope that soon it will start. Okay. So now I'm showing you how to create the virtual machine on Windows. But if you like to use the virtual machine with Linux, you can also do that. If you want to get something like a tutorial, please visit our YouTube channel. There are tutorials available to create virtual machines with Windows and also with Linux. Okay, I see that it has some problems to start. But let's give it some time. Okay, so the user password must be changed before signing in. Okay, so now it will be a bit of fun to move the mouse on it. Okay, because we have two mouses. So we click on the password. So let's create the password. Okay. Okay, my fault. Let's. Okay, this one. Okay. I'm not writing. I'm sorry for this inconvenience. Let's see. Okay, didn't match as well. Again. Didn't match. Let's try. Yes, now I'm in. So the password has been changed. So I can move back to the instances. And okay, from this span. So you will see the windows here, but we won't use this console. I will move to the instances because we need, if we want to get to our virtual machine from the remote desktop or from any other application, we have to do one more thing. We have to associate floating IP, because IP, this is something which is really needed to connect the virtual machine. So let's associate the floating IP. So I have here already some IP addresses I have already used, but let's say I'm a new user, so I will add the new IP. So I will choose the external, and I will allocate the IP, the external network, and my IP will be allocated there. And then I have to indicate the port to be associated with my IP address. So yes, Go2Space associate. We are waiting for this configuration. After it's done, we can see that we have a floating IP. So we can copy this floating IP. It will be needed for our remote desktop connection. Yes, but I think that this will be also tricky to show you my remote desktop. I will see if I can. Okay, unfortunately, I cannot. I think I cannot share my computer screen. Only the application. But okay, let's check. The remote desktop. And also question, can you see that I'm now trying to connect remote desktop?
We can see your your screen.
Okay, but can you see only the presentation, or can you see also some screen in Polish, like a remote desktop connection?
No,
we can see your Blackboard platform, your collaboration.
Okay.
Your collaboration.
Oh, okay. So, okay. Maybe I can try again. But it seems. Okay, I will try again. I will try to connect again. Can you see that now I'm trying to connect? Okay. So yes, so as it works now, what password I have created? Okay. Again, my question, can you see remote desktop? Okay, I can see. I see that you can see it. Okay, so this is my remote desktop. So this is the virtual machine we have just created. So for example, I will now show you what disks are available. If we go to this PC, we can see that only the disk C is available. But I would like to connect to Earth observation data disk. So here on the desktop, you can see the script which helps you to connect directly to Earth observation disk. So it should be connected in a couple of minutes, but sometimes it's a bit tricky and it's not so easy to connect. So then we should go to command line. Yes, and we should indicate the IP of the Earth observation disk. Okay. Okay, now it's connected. Maybe I'll just enter it again. Maybe again the script. Okay, so now you can see that I have been connected to the data repository. So when I will open the data repository, we will be able to see the data sets available in our repository, in the CREODIAS repository. Of course, we need some time to connect to it, as it's always. But what is also important here, so when you establish your virtual machine, mine is without any software. You can download the software and you can install any software on this virtual machine, and then you don't need to download the data. So you don't need to use, for example, Earth observation hub or CREODIAS to find the data and to download the data to your computer, because here on the virtual machine you get the access to the data directly. So no need to download the data. So when you are using ArcGIS, when you are using QGIS, when you are using any other software for data processing, you can connect the data in your software. So the repository is now available, so you can see all of the data sets which are available here. So for example, Sentinel-2, when we go to Sentinel-2 folder, we can see the data from 2015 and 2020, so the future. But let's see the data from 2020. It's going to be a lot of the data. So the data are cataloged month by month, so from the whole year, and then from all of the locations. So it's really huge data repository. But let's see, for example, February last year and the 2nd, for example, of the February. It's going to be open soon. So here you can see all of the data sets from this date. If you know the path of the data of the place of your interest, you can search for it. I will open one of it just to see the preview of the data set. Okay, it should be open by now. Okay, so just a part of the world which was captured by Sentinel-2 data. But if I would have any remote sensing software, any software which opens the Sentinel data, I could preview the data in the software. So this is the virtual machine. You can use it, you can process the data, you can access the data, you can do everything in your virtual machine. So Okay, so I will stop, or I will just come back to my presentation. And come back to the slides. So this was actually all from this technical session, from this practice session. And I really encourage you to visit our website and to visit our YouTube channel, to watch our records from our webinars, and also visit CREODIAS website and make a use of the website of the platform, apply for the free credits. And whenever you have any question, you can address them directly to me or my colleagues from the support. I see that there were some questions on chat. I don't know if we have time, but I see that most of it were answers to my questions, so thank you for that. So I think that the best would be not to take time now for questions, but you can send email to me and I will answer your questions. So I would like to also thank you for this time. And the next presentation will be very interesting because it will be about S2GLC project, about S2GLC product, which is available on CREODIAS. The presentation by Professor Stanisław Lewiński from Space Research Center. And I hope that you will enjoy this week of the Go2Space Hackathon. So thank you very much. And here you can find links to our websites, to our social media, and also my email. So whenever you have any question connected with the CREODIAS platform, connected to cloud computing, please write me an email and I will be happy to answer. So thank you very much.
Thank you, Klaudia. Now is the time to learn about Klaudia's use case. Professor Stanisław Lewiński, are you there?
Yes. I'm here, but I need some time for sharing my presentation. I think it will be not so difficult, but you know, for me it will be the first time to do it using this software.
Okay.
But, yeah. No, I have some problems. It looks that the software stopped.
Okay, maybe I will help. Should be.
Yes, please.
Udostępniaj pliki from the share screen.
But in the instruction was share.
Yes, there is a share, and then after accessing the share, there is udostępnione pliki. So share documents, shared files. So I had to upload my presentation.
Okay.
Professor, do you want to share your screen or upload your presentation?
No. One moment. I think that, you know, I'm on the. Okay. Please wait more. 2 seconds. 1 second. In this moment, my presentation is converted.
Okay, perfect.
So it looks that it works. I was sure that it will be possible to make presentations without conversion. Okay. One moment. Okay. Do you see my presentation?
Yes. Yes, it's okay.
Yes.
Yes.
It's okay. Fine. Thank you. Thank you for this information. I need still some time. Oh, no, because in this moment I have something. Okay. Okay. In this moment, from on my screen, all works well. So I can start, and sorry for this few minutes for waiting for my presentation. But in this moment, I lose my presentation. So it's once again.
We can see the slides.
But I don't see it. I don't see my presentation. I see a set.
One second,
of
Professor. I
images.
try to upload your presentation and share with mine. Now you can see
Yes.
your presentation?
Yes.
Okay.
Okay, and can I change slides or not?
Yes, you can move your slide. The slide.
Okay, okay. Sorry. Okay, in this moment is the first slide. So I can start. And the title of my presentation is Sentinel-2 Global Land Cover, and it is the abbreviation of this title is STGLC. It's abbreviation of our ESA project. Presentation, it will be about 20-25 minutes, and here is a short plan of it. I will talk about two phases of our project, about strategy, classification legend, classifiers, selection of training points. And next, I will present you our final work. It is land cover map of the whole Europe. And the last part, it will be epilogue. Epilogue, it means what happened after the end of our project. It was Sentinel-2 Global Land Cover. It was ESA project. This project was led by CBK PAN. So it means Space Research Center of the Polish Academy of Sciences. And we collaborate with our German colleagues from IABG company, EOI Explore, and also from University of Jena. The goal of this project, it was development of classification methodology and strategy, and we have to develop classification approach which will be ready for global mapping using Sentinel-2 images. We have, at the beginning of our work, ESA defined some assumptions. So they have that we will process time series of images, that the resolution of the final product, it will be 10 by 10 meters, so the size of pixel of Sentinel-2, automatization as much as possible. And as I told, approach ready for global classification. It was the goal of our work. And at the beginning, in our opinion, we had a feeling that it will be not so difficult because it is necessary to just to define legend. Next will be time for definition of classifier, training points, and it will be the end of the project. But shortly we recognize that it will be not so easy. The first step of our research work, it was review of existing global land cover databases, because it was necessary to have a deep knowledge how these databases were prepared. We tested about 12 databases, and we noticed that in the case of classification of Sentinel-2, we should be concentrated only on homogeneous news land cover classes. So we didn't looked, or we were oriented on heterogeneous classes. And next slide is a good example of this heterogeneous class. It is a savanna. In the case of low resolution database, savanna is just like one land cover class. But from the point of view of the size of Sentinel, pixel size of Sentinel-2, we have grasses, bare soil, trees, or some bushes. After review of existing databases, we decided we prepare our classification legend. The structure is typical for land cover classification work. So it's a hierarchical structure. It consists of 3 levels, and we classified the last one. So it means that we classify 15 land cover classes. Selection of classifier. We tested a lot of classifiers. We looked at supervised classification and also at unsupervised tools. You know that is big difference between supervised and unsupervised classification, but speaking frankly, the most important part of each one is the access to reference data. And this access is especially important in the case of global mapping. Here is an example of our tests. We test random forest boosting support vector machine, and these tests were performed using this same satellite image, and we looked at the results: overall accuracy, time of learning, time of classifying, also the possibility of automatic selection of classification future, and also what is very important, access to prediction score. Prediction score, it is the probability of classification. And also, we look at comparability of prediction scores, because in the case of some classifiers, it's very difficult to make a comparison between results. And the last point, we looked only on open source approaches, classifiers. Next one, okay. Our German, sorry, I'm going back. One slide. Okay. Our German, sorry. I should wait. Okay, I was impatient. Our German colleagues try to find solution for collecting training points. And, you know, it's very important when we are talking about automatic classification in global scale, because in the case of 1 or 2 or 5 images, it's not difficult to define training points. But when we are talking about or thinking about global scale, it is the most important, one of the most important parts, how to collect training points. And we tested a few solutions, but always at the end of this workflow, we had 2 gentlemen for checking, for manual checking. But you know, this idea is not acceptable in the case of global mapping. So we try to eliminate these 2 gentlemen. And we found that, you know, that is just one solution, and still we are sure that this maybe is not the one solution, but it's really a good solution, that in the case of global mapping, it's possible to use existing low-resolution databases as reference data. And here is example that we have example of 4 existing low-resolution databases. They were prepared based on low-resolution satellite images like MODIS, MERIS. Also, we tested databases prepared based on NOAA images. You know, here is a situation that I'm talking about low-resolution databases which were used as references in classification, 10 by 10 meter pixel. But and so it is against some common rules, but it works if the training data are well prepared. Here is our classification approach. So on the left side, we have a time series of Sentinel-2 images. The images are classified using random forest classifier. But we don't decided to classify time series. We classify time series by this way that each image was classified separately. And after each classification, we collect not only the final results of this classification, but also information about prediction score. So it means that we had information about a class and also the probability of this classification. And next was performed aggregation, and after aggregation aggregation of all these single classification, and the final classification, it was a result of this aggregation. How this aggregation works, it will be presented at this slide. So it's just, you know, for example, that we have a 7 classification, and we are looking at 1 pixel of this image. And one time this pixel was classified as class number 1. Next time like class 2. And also we have information about prediction score. Using very simple computation is possible to compute parameters, and based on it, it's possible to say that, okay, this pixel was a few times classified as this and this class, but the best result was achieved for class number 1. And in the case of this pixel, the final result, it was class 1. On the top of this slide is presented idea that we have high resolution satellite images. We are using low resolution database for training. Next, we have high resolution land cover classification. Below is a second advantage of this our approach, because using aggregation, it's possible to use not only one database for selecting training points, but a few. And so it means that we can classify a set of images using the first database. This same set of images is classified using second database and next database. So we have a stack of classification. Next is perform aggregation, and we have the final result. And if you are using more than one databases as references, the final result is improved. Okay, I'm waiting for the next slide. Okay, here is a more complicated workflow of our classification strategy. But what is important? That we use pixel-based classification. We use random forest as a classifier. We develop aggregation, and training was performed existing low resolution databases. And during the training pixels were selected randomly and separately for each classification. The last point is automation. And I have to say that we reach the level that this classification is almost automated. And we are using software prepared by us, so it's CBK PAN software. This classification approach was tested for 5 selected study area. They were, it was not just single images, because we classified the whole Germany, the whole Italy, also a piece of Namibia, Colombia, and China, and each time the size of our study areas were comparable to the size of Germany and Italy. At this slide, we have the results of our classification. Here is also information about our area of the study area, how Sentinel-2 tiles were classified, how many images per tile we use, because as I told, we classify multi-temporal images. It's information about low resolution database used for training, and at the end is the results of validation. And please look that in the case of Italy, Germany and Italy, our results are on this same level like Korean land cover database. Of course, in the case of Korean land cover, we have a lot of land cover classes, and but you know but our classification was performed automatically without any support of manual work. At the end of our ISA project, because of very promising our results, decided to make extension of our project, and we call it that it was a phase 2 of our project. And ISA proposed us to classify the whole Europe using CREODIAS, because before all computation were performed in CBK PAN, here it was ESA, I can say, push us towards CREODIAS. It was also a kind of checking. It's possible to use CREODIAS for big, so huge land cover classification. At the beginning of this this part of the project, we tried to improve our classification approach. We perform a lot of not a lot, as we perform some tests, and we decided that we will use as references Korean land cover and also high resolution layers. We defined classification legend, which was a little modified comparing for this legend, which was defined for the global mapping. And also we defined some rules for selecting training points. So the main source of the training, it was Korean land cover. We use high resolution layers and also water index and NDVI for filtration, for improving this training. From the point of view of computations, our software prepared by us was adopted to CREODIAS, and as I know, because I'm not a programmer, as I know that it was not so difficult for our programmers to move all software to CREODIAS, but also it was necessary to prepare. I'm waiting for slide. Sorry, I'm going back. And also, we prepare a special tools for batch processing because you know it was we didn't use just one virtual machine. We use usually over 40 virtual machines, so it was necessary to have a good a good tools for batch processing, and it was by us with some support from CREODIAS at the beginning. And here is the final results of our classification. So we classify 815 Sentinel-2 tiles because we use multi-temporal data, so it means that over 15,000 classifications were performed. And the final mosaic was prepared by colleagues from CloudFerro, CREODIAS, and at that moment they helped us a lot, really a lot. Next, okay, here we have results of our classification. In the case of 13 land cover classes, it was 86%. In the case after the merging some agriculture classes, the final overall accuracy was 98%, and the validation was performed based on over 50,000 points. And you know, it was the end of our project. At the end of 2019 was Geo Summit in Canberra in Australia, and ESA and also European Commission, they selected our map as a front image of European stand, and also Patrick Child, who is responsible for research research in European Commission, he told about new Sentinel satellites standing in front of our map. ESA prepared a success story about this classification. So the title is Land Cover Maps of Europe from Cloud. Cloud is, it means from CREODIAS. And also it's possible to find some information, results of our classification using CREODIAS browser, because all tiles are available. At CREODIAS also is, sorry, before was CREODIAS Finder, now we have CREODIAS browser, and is really very, I like this tool very much, because you know it's possible to go through the whole Europe looking at our land cover classification. Some detailed information, including publication, is possible to find at our project web page. And in this moment, you know, is a prologue of our work, because at the end of previous year, during 1 week, it was enough, about 5 days, to classify the whole Poland, and it was done. It was done also using CREODIAS infrastructure, and it was order of the Polish space agency. And I hope that shortly this map of Poland, classification map of Poland, will be available, similar like our Europe at CREODIAS. And this is the last slide of my presentation. So it was a use case. Maybe, in my opinion, we are very close to say that it was a success story. Why very close? Because please look, we started from global scale. Next was Europe. Next was a country's scale. Now our dream is to have possibility return to Europe and to classify the whole Europe once again. And you know, it's difficult to calculate the time of this work, but I think 5-6 weeks it is enough to have. It will be enough to process all images covered the whole Europe. And it is the last slide of my presentation. Many thanks.
Thanks, Professor. Thanks, Klaudia, for this training session on CREODIAS. To end today's session, we will learn more about space-enabling technologies. In this case, about how data can be used to build smart cities. Let me introduce you to Inés Huertas, an expert in big data and machine learning, and also the coordinator in Madrid of Our Ladies, an organization that promotes gender diversity in the community of users of the statistical programming language R. Inés, are you there? Welcome. Inés?
Hello.
Hello. Can you hear me?
Yeah, I can. Can you see me?
No, I can see you.
And now?
Now, no. Yes, I see you.
Hello. Cool. Hello, everyone. Cool. Okay, I can manage the presentation. Emma?
Yes, you can manage the presentation if you want.
Ah, okay.
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 Perfect.
Thank you.
Go ahead. The floor is yours.
Hello again. I know that it's late. I know that I am the last one, and I will try to make some quickly, because I want to share with you different pet projects that I was working in last year for help you or inspire you. If you need some information more that I can give you in this presentation, in this slot, you can write me, and I try to give you more information or more resource about this project. But first of all, I want to say thank you to Go2Space Hub for inviting me to be here with you today. Let me, first of all, I want to introduce myself because some of the projects that I will show you was working in different areas of my life, not in the professional area, inside in the communities areas or other projects that I was working, like data nodes. I am Inés Huertas. I am big data and machine learning expert. I am part of Our Ladies Madrid organizer. That is a community here in Madrid. It's an international community that try to push visibility and recognize the work of the women that program in R. and I am the local in Madrid that works with the local community. And in 2017, I was chosen by Datanauts program to participate in it. Datanauts program is a part of Open Data NASA that try to use the open data that NASA has, because it has a lot of data, and they try to explore and explode in a social context with different profiles working in different areas. And I will share with you some of the pet projects that I was working. And this is my Twitter. And if you want to contact with me, this is perfect. And well, we start with the Open Data NASA Pets projects. And when I start in Datanauts program, I have a lot of problems because I have a technical engineering baggage, but I didn't know so much about the data for NASA. So this is the link that you can find a lot of catalogs with open data and a lot of links to other resources that maybe could be used for you. And in my first step, trying to explore and explode this data, I start with this pet project that is a small project, but I think that could be cool because it's a project about firewalls. You can find in this site, Neos project. Hello? I hear me again, but I think that is okay. Cool. In this website, you can. Hello, Emma?
It's okay, Inés.
Ah, cool. Because I hear me myself, and it's weird. Okay. In this website, you can find a lot of data about firewalls, and you can find historic data about it. And it's very easy. You can download the TBS file. It's very clean. You don't have to do so much process about this data. It's plain text. And if you need to pre-process the data to find the month of the year, this is okay, but it's very clean. You have 735 samples, and in this data you can find the date that the firewall fall, the latitude, longitude, velocity, and impact energy. Okay, in this website you can see other things. You can see visualizing about this data, and you can start to work. I did this one in R, and I was working to trying to find pattern between the season of the year and the impact zones, the size, the velocity, and it's a very easy data set to start to work with data. Other work that other pet project that I was working is about Earth Observatory in the NEOS website. This is really big treasure of data, because in this website you can find data about Earth observation of different areas at most energy, land, ocean. You have a lot of data, and you have the historical data. This is the most important, because if you have historical data, you can start to work with time series, trying to predict in the future, for example, what is the radiation that you will have next year, or trying to correlate to variables like ORL and albedo, or CO2, or whatever you want to find. No? But the problem, when I start to work with that, is that the information was like in an image. You don't have a data set with the albedo that you have in one side of the world in one day. No, you have one day, one image. But you can work with this one using an image like a matrix. And this is that I try to in this pet project. I say, okay, I only have the image. I try to convert this image to a matrix to work with. So we have if I have a matrix about the image, for where Alberto, for example, in January 2016, I tried to model this data in one array to process or try to process, no? And this is what I did. I get the image, I convert it to one matrix, and then try to manage this data in one structure of one array. In that way, I can have this array with the with one observation of one variable like albedo in one day. So if I can do that, I can do this one for each day, trying to concatenate each array, each one, and try to get a big array with all observation of albedo in different states. The idea is trying to do this one with one variable like albedo and other variable like radiation, OLR, and try to find some correlation because the right has the same position, and I can find when one has one level and the other two. And this is one of the projects that you can find in this GitHub repository. Is open. If one of you want to participate or want to add some idea, is welcome for us. Other project that I want to share with you is one that we do in 2019, trying to predict biosphere behavior. And this project we present to the Big Things Congress. The Big Things Congress is like a big data congress here in Spain. And there is a lot of relevant people of the big data area talking in this congress. And I give a talk with Moises Martinez. This is Moises, and you have here his Twitter. And one day Moises and me, we were thinking about, okay, we want to participate in this congress, what we can present. And we find a big database about bird migration. And we start to think, okay, we have a lot of data, historical data about bird migration. And it's very funny because it's not funny, it's normal for the birds, you know. Bird migration are the movement that the birds made from the north to the south when the temperature is cold in the north, and then come to the north in summer, no? And we say, okay, maybe if the temperature of the planet, the Earth, are each time more and more, the climate is changed. Is the bird migration changing too about the temperature that is higher? We can try to research about it, and we start to see that there is a lot of news and a lot of studies that they are saying things like that, no? And we say, okay, maybe we can try to merge the data of this database about bird migration with data about the temperature, CO2. Try to find some correlation with these two variables. And we try to do all of this one using a Google Cloud platform. And this is a simulation. Oh, doesn't work. It's a GIF about the Emma. Yes. I don't know if you can. This is a GIF that they move and you can see the path of the birds.
Okay,
I don't know.
Second. Maybe I can share my screen 1 second and see the GIF.
No worry. I can give you the link in the where you can see the YouTube talk about how we implement all of this. This is our abstract, okay? But it's very fun because you can see the birds in January, February, March, and you can see that they down and they go up. But no problem if you are interested. In the end, I have the link to the YouTube talk. In
Perfect.
this way,
Thank you.
In this way, we develop a pipeline using Google Cloud, using Jupyter Notebook. We develop a easy TensorFlow model, and we deploy it. But the result was very poor, and we say, okay, we deploy a lot of things. We deploy a pipeline, a Google Cloud platform. We make a lot of things, but we cannot predict the global biosphere behavior because we need more data. We are only comparing. I think that only we use the temperature. Maybe we can use more. If you are interested in this project and want to enrich it, you are welcome. You can write me. I think that we have a GitHub too about it. I have to search it, but I can give it to you. And the last one that I want to share with you is a pet project too that I make about the smart cities. And all of these start with each year in Madrid, we have the Smart Cities Congress, and all years I say, okay, I have to write something and try to send, try to publish in this congress because I am a smart city lover and I was crazy with this topic because I think that we have a lot of things that we can improve our cities, no? And I was looking for a project to test, and I find this website. This website sells webcams, okay? And they have a webcam looking into Callao Square in Madrid. That is one of the most bigger square here in Madrid. And they are all time giving a video in real time about the square. And I say, okay, we have a lot of data here. I can only make a program that try to download each time that I want image and try all. I store these images and try to process them. So I develop a web scraping that give that make up a picture each 20 minutes. And I start to store it. When I have 1 month of image, around 1,000 of image, I start to prepare this image because they was very big. We have a lot of buildings. I don't need the buildings because my aim here is trying to calculate the percentage of people that the image has. In this way, I can say, okay, in this image we have 18% of occupation. In this one we have 25, and I want to try to automate all of this, no? So I split the data. I make a training sample with a lot of people making labeling in the image, and then develop a neural network that with some layers we have 80% of precision to say, okay, in this image we have 75% of occupation. With this one, then I say, okay, but I know how many percent of occupation have the squares in each moment of the day in a week. I will try to correlate this one with the bus frequency, trying to discover if when we have a lot of people in the square, we should have a lot of frequency of bus. But when the occupation in the square is less, we must to have less frequency of bus. And this is what I find. I find with a percentage of occupation of the square was high, the frequency of the bus was high too. But when the frequency of the occupation was less, the frequency of bus is still high. And I say, wow, this is a problem because, well, it's not a problem, but we can improve all of these resources and maybe in other part of the city. And if we have more tools like that connected to big data platform, we can automate say, okay, we have more people in this area, we can move this bus to this other other place that we need more because there is a more percent of occupation. And this is all. I hope that you like all of these PETS projects. And if you need more information, if you need more, I don't know, resource or link about this project, you can reach me in the in this email. And I don't know if you need more. It's a pleasure for me to be here.
Thank you, Inés. We are on just time. We are perfect on time. Thank you very much. Many thanks to all the speakers. Today we had some very interesting speeches and we had learned more about the ONDA platform and have the first of formations of this event with CREODIAS. Tomorrow it will be the turn of two other platforms, MINSC Web Services and Wekeo, with some use cases. And on Thursday we will have Soblo training. I remind you, CREODIAS and Soblo will be used during the teamwork days, Friday and Saturday, with technical support. From now, you have access to both platforms. Many thanks to all the speakers and participants. See you tomorrow.